Good morning students, God bless you. Welcome to maths class. In this class, we are going to see about properties of rational numbers. What are the properties are you have means closure, commutative, associative, identity, inverse and distributive property. These all properties are we have in our syllabus. And then depend upon the operation wise we get the results. I clearly chart out the results only now. So I explain the operations are addition, multiplication, subtraction, division. Okay. Addition wise the closure property is true under addition. Commutative property true by addition. Associative property is true under the addition. Identity property is true under addition. Inverse property true under addition. Okay. We clear the result only. So all properties are true under addition. Have you understood? After I explain the example wise. Okay. Next the multiplication. Multiplication wise closure, commutative, associative, identity. The first four properties are true under multiplication. The inverse property is only is not true under multiplication. Okay. Then subtraction wise only true for closure property. Another all properties are false. Okay. Then the division all properties are false under division. Have I understood the result? After I explain in detail all the properties. Okay, we have the four fundamental operation. These operations, which property is true and which are not is false. They given the results of properties. Have you understood? Okay, dear students. The first one is the addition operation. So addition wise, now we have discussed the properties. Okay, the first one is the closure. Closure means if you choose any two integer or rational number, if we add the two integers or rational number, we get the another one rational number. This is called closure property. That means a plus b is a rational number. That is a plus b is belongs to q, the rational number q. So example of closure property, I will select so 1 by 2 and 3 by 2. So addition of these two are rational number. Cast in the form of a by b and denominator is not equal to 0. This is the rational number definition. So here I will select two numbers from the rational number. So addition of two value must be 1 to the rational number. To get the rational number, the result, the closure property is true under addition. So 1 by 2 plus 3 by 2 is equal to, these two are like fractions, so denominator is common, 1 plus 3 is equal to 4 by 2 is equal to 1 2s are 2, 2 2s are 4. So 2 by 1 or 2, every integer is a rational number. So we get addition of two value in Q. 2 is belongs to Q. Okay. So have you understood the closure property? So closure property true under addition. Are you clear? Next, what is the name of the property? So commutative. Commutative property a plus b is equal to b plus a. This is a commutative property. You add a plus b equal to b plus a. This is your result of commutative property. Here also I have used 1 by 2 and 3 by 2. So we have to check A is here 1 by 2, B is equal to 3 by 2. 1 by 2 plus 3 by 2 is equal to, first choose the LHS side, left hand side. This is LHS. So RHS B is equal to 3 by 2 plus A is equal to 1 by 2. 2, 1 plus 3. This is equal to 2, 3 plus 1. 1 plus 3 is equal to 4, 4 by 2, which is equal to 3 plus 1 as well as 4, 4 by 2. So using the cancellation, this is 2, this is 2. 2 is equal to 2. So the condition is satisfied. So comrading property true under addition. You understood? The closure property true under addition and comrading property true under addition. Next, the third property, Std property. Associative property. You select any three rational numbers A, B, C. The A, B, C write in the form of A plus B plus C is equal to A plus B plus C. This is associative property. Associated first two elements, then add the third one. And first number added second and third association value. Okay, this is associative property. So now also check. Let us consider any three rational number 1 by 2, 2 by 2, and 3 by 2. These three are rational numbers. Is that not? Yes. Okay, so applying the property, A is 1 by 2 plus B is 2 by 2, then associated plus this is 3 by 2, which is equal to A is 1 by 2 plus this is 2 by 2 plus 3 by 2. Okay, have you understood? Just I have substituting the given value. So 1 by 2, 2 by 2, 3 by 2. Okay. Then already you have one board law. This is for Bohr-Morse law. The B represents the bracket of division, multiplication, addition and subtraction. So this is a Bohr-Morse law. So first to do in the bracket of division, multiplication, addition and subtraction. So the bracket value first you do it. So this is for 2. So 1 plus 2 is 3 plus 3 by 2. This 3 by 2. Plus 1 by 2 plus the common is 2 and 2 plus 3 is 5. Okay. Then here also exists the like fraction. Only compare the numerator. 3 plus 3 is equal to 6. This is equal to 2 is the common. Then 1 plus 5 is equal to 6. 6 by 6 is equal to 6 by 2 is equal to 6 by 2. Or using the cancellation 1 2s are 2, 3 2s are 6. 3 is equal to 3. Okay, I understood. So satisfy the associative property. Associative property true under addition. Very clear. Before I start the explanation, clearly I given the chart. What other properties are true under the corresponding operation? Okay, next, what is the property? Identity. So one of the property, identity property. Okay. So identity element of addition is 0. Identity element of addition is 0. Identity element of multiplication is 1. So 0. The property is so a plus 0 is equal to 0 plus a is equal to a. Okay. This is the identity. So if you select any one number, the number added to 0, we get the same number. So identity element of addition. Here I select any one rational number 1 by 2. Say replacing here 1 by 2 plus 0. What we get? 1 by 2 plus 0 means 1 by 2. Then 0 plus a. 0 plus a. 1 by 2 is equal to 1 by 2. What is a? 1 by 2 is a. So this property is true under addition. Okay. Then inverse property. Inverse property, a plus minus a equal to 0. The inverse property X is the identity element of addition. Okay. So under addition, X is the inverse 0. Okay. This is the inverse property. This is equal to minus a plus a equal to 0. Okay. This is your inverse property under addition. Okay. So addition means between used only the addition of symbol plus plus plus. This is one number, this is one number. In between use the addition. Suppose subtraction means here use subtraction, subtraction. That only change, but properties are same. Okay. So here I consider 1 by 2 means the 1 by 2 plus minus a means minus 1 by 2. This is equal to 1 by 2 plus into minus minus 1 by 2. So 1 by 2 minus 1 by 2 get 0. Then the same manner minus a minus 1 by 2. Now I check this RHS. 1 by 2 plus plus a 1 by 2. You get minus 1 by 2 plus 1 by 2 0. So the answer is the identity element. It is the inverse property. Have you understood the properties of then multiplication? The same manner, then first the closure property. When multiplying any two numbers, we get one of the rational number means the closure property true under multiplication. This a into b belongs to q. This is the closure property under multiplication because multiplication symbol used here. Okay. So now I am select 1 by 2 and 2 by 2. The same number. Okay. How to check any other? Select any one number, any two rational number. How to check the conditions? This is your homework. Okay. 1 by 2, comma 2 by 2 means 1 by 2 into 2 by 2. This is equal to 1 2s are 2, 2 2s are 4. This is equivalent. This is belongs to q because 2 by 4 is the one of the rational number. Okay, the result is also a rational number. When you select any two rational number, the multiplication of two numbers also a rational number. Okay, this is closure property. Closure property true under multiplication. Next, commutative property. Commutative. This is what a into b is equal to b into a. This is a commutative property. A into b is equal to b into a. So select any one number. So a is 1 by 2, b is 2 by 2. The same example means b is equal to 1 by 2 means 1 by 2 into 2 by 2. This is equal to 2 by 2 into 1 by 2. 1 2s are 2, 2 2s are 4. This is equal to 1 2s are 2, 2 2s are 4. The LHS and RHS are same. Okay, this is a commutative property. Okay. This like you do, we get all the results. Okay, next, the third one identity property, fourth is the inverse property under multiplication. Identity property, this identity element is 1. Okay, under multiplication identity element 1, under addition identity element is 0. That's all. So the identity property is a into 1 is equal to 1 into a equal to a. So this is the identity element. So must be 1 to the given number. So a. Here inverse property, you select any number a. So multiplying by the inverse of the same number is equal to identity element. 1 by a into a is equal to 1. The inverse property under multiplication. Okay, so inverse property. That's all. You have to check the corresponding examples. You have many examples in your book, so do it at home. Okay. Then the subtraction. The subtraction, the closure property. Closure property, a minus b is belongs to q. This is true. Cause closure property true under subtraction. You do any one number, so 1 by 2 minus 2 by 2. The same example means, so 2 is the common factor. 1 minus 2. 1 minus 2. What you get? This is plus, this is minus. Different numbers means you get the subtraction. So subtract greater number to smaller number. 2 minus 1, 1. The greater only sign minus. Minus 1 by 2. This is one of the rational number. So belongs to Q. So closure property true under subtraction. So now all other properties are false under the subtraction. What other properties are there? Commutative. Commutative property and associative, identity and inverse. So commutative property under subtraction, so a minus b is equal to b minus a. This is not equal. Okay, you have to check. You have a home. This is your homework. We select any rational number for a and b. So check the condition. First subtract a minus b and b minus a. This is not equivalent. Okay, this commutative property falls under subtraction. Associative property, a minus b minus c is equal to, does not be equal to a minus b minus c. Okay, this is the associative property. Okay, then identity property not be exists. The same inverse also not be exists. Then the division, closure property is true under division, because the tabulated type I giving a tick mark because the rational number only satisfy the condition. Integer, if you take, the closure property is not true under division. So only true for the rational number, the closure property. So the example is, suppose you take a is equal to 2, b is equal to 3 means division of two number must be gone to integer. So a divided by b must be gone to integer. Okay, the two numbers. So check 2 divided by 3. This is equal to 2 divided by 3. This is does not belongs to z. Because 2 by 3 is a rational number. This belongs to q only. When I select two numbers from the integer, the answer also on to the integers. But here exists the rational number type. This is not a closure. So when the integer selected, otherwise if you select any rational number, two rational number, 1 by 2 divided by 2 by 2 means this is equal to 1 by 2. The division change into the multiplication. Change the numerator and denominator. You get 1 2s are 2, 2 2s are 4. This is one of the rational number. So now true closure property. Have you understood? Okay. So this is only true. All other false. So commutative property. So a divide b is not equal to b divide a. Then the associative property, a divide b associated divide c is not equal to a divide b divide c. And identity and inverse as well as does not be exist. Okay, have you understood? Okay, dear students, in this class homework book page number 24, 25, 26, 27, 28, all examples. Okay, you have a book, textbook, work out clearly and send my mobile number. Okay, individually, don't send in the WhatsApp group. Okay, thank you, God bless you.